Today we are going to talk about drafting molding. Now I'm doing this at home on my home computer, so if you hear a little 5 or 3-year-old monster run in the room, those are my kids. I just put them to bed, but any parent knows that doesn't mean anything. So, all right, let's get started. I'm gonna try to do this in one take. So what I do, and please drop a comment in the comment section below how you guys do it, but how I do it, I take a cutoff, I cut like a 1/2 inch thick piece of molding, I put it on edge, so that's the end grain. I put it on a flat, perfectly flat piece of material that I've cut on the CNC at our shop, and then I scan it. Then I go ahead and take calipers and I mic the thickness and width. That's why it's 4 decimal places. It's as accurate as you can get it and as close as you can get it. At the end of the day, you are eyeballing it. Sometimes there's a little shadow. I wish my crosshairs weren't white. I always trace it in blue or red to help with that. But that's what I do. I'll give you a sneak peek. This would be a finished product of a different molding. And I won't bore you with too much detail, but I've seen people that have shown me in the past. I would actually go through and dimension all these out if I was really doing this for the big show, but I'm not gonna do that. Just gonna eyeball it, freeball it. What I was gonna say, I'll show you. What I've seen some people do, if I take my ortho off, is they literally draft in circles, and I'm not gonna say names on who showed me this, but they're a wizard, and they could literally like join the arcs together perfectly. I can't do that. I can't do that. I'm sorry. I'm not that good. Call me old school. But this is kind of what I do. I'm using AutoCAD student version from my college days, but you can use just about anything. Don't love that. Don't love it, but pitter patter. Let's get at her. Yeah, sometimes I get in the zone. I don't love that either. I don't love it. I don't like it. I'm not married to it. What? We'll clean her up. Yeah, like see like the kind of the scan, I would call that scan noise. I've tried to refine our scanner and really sometimes you gotta turn snap off. I've really tried to dial in the scanner, and like that. It's close enough for now. Yeah, I tried to dial in the scanner and just can't get it much more refined than that. We will come back and edit this, don't worry. But yeah, this is gonna be a quick video. I didn't post one last week. It was Easter weekend. I was out of town, and I didn't want to rush anything. That's the worst. I feel like you guys would definitely know when it's rushed, and that's gross. But it's not all about the shop. I would definitely, to mention this. I'm just literally eyeballing this whole drawing right now for this video, but it's ideal to, like, with your calipers, micrometer, whatever you want to call it, either one, and like go through, measure that point, go here, you know, measure your highest point, and just make sure that, you know, along the way you're hitting your points. So one thing about tooling is you cannot have, well, you actually can. On our Weinig grinder, you can use a square grinding wheel, but we have a really good grinderman at work. This just heats up too much. There's nothing he can do about it. So, a little fun fact for those that don't do this, 2-degree bevel. This desk at home is shaky. My wife uses a stand-up desk, and if I just lightly press on the desk, it shakes. It's driving me nuts. Let me try this spot. So that line's a little high. That is okay. When we're setting up the machine, if it is a hair, I mean, we're zoomed in a ton right now. If it seems like it's a little high, and when I say a little high, I'm talking maybe the profile instead of 8129 is actually gonna, you know, right now, well, it's 8129, but when we set up the molder, we could literally take this down to like 810 or 807 5,000ths, and it'll clean that up. So what I do on this, fill it, and it's just kind of guessing sometimes. Let's try an 1/8. Oh, too much. AutoCAD will kind of tell you, like, hey, it's too much. I like to use actual geometry. I've seen a lot of samples over the years that were probably hand planed, and what's going on with this one here? Or just people just tracing with arcs. That should be. Oof, man, I feel like I could get that better. So one thing to notice, I'll work on this, but that's how I draw it. Like these inside corners, even this one here, you can put a fillet in there if you want, an inside radius of 0.02. Won't even let you. Why is it doing that? Normally I don't have these issues. Of course, when I record, I do. So like that. I would even smooth that little radius out there. Perfect. You can, like I just did over here, put that 2-inch radius, or your tracing pin, the smallest one, typically is 2 millimeters. It's gonna round that corner off when you're coming through with your tracing pin coming down. So you can either draft it that way or just leave it like this, and your 2 millimeter is not going to reach there. We do actually have a 1 millimeter grinding wheel, CBN wheel. So I guess you could use that one and get it as tight as possible. But just to recap, having that 2-degree bevel really helps with the knife not heating up as much. So that's a quick little deal there. That's my trace, and I guarantee you this, like, you can see the material was warped a little bit, so it's kind of coming up off the page here, or off the flat edge. I guarantee you, if I went to the printer, printed this off, and laid this sample piece over it, it would be a 98% match. The only issue I don't love is this radius. I could just do individual arc and get it even tighter. But for the video, I'm going to leave it, and we will shoot over here. So this is the finished product. The, oh man. So I drafted this in red, and then I forgot to change my layer, and it went back to white. But this white, we'll say, line, so these three, and then this line and this line are your templates. That's your template. Rule of thumb, always make a template 4 inches wide. And then your template depth is taking the highest point of the profile plus 2.362. See? Not just making up numbers. Sadly, I have all these numbers memorized. Drafting 1,000 profiles over the years. So that's how you get your template depth. It's always 2.362 above your highest point, which would be your max depth of cut. Sorry. No. I always thought when I was a kid that I was dyslexic, and now that the fact that there's minimum radius and maximum radius, staring at tooling all day, that is your minimum radius. I'm sorry, I said max depth of cut. Your max depth of cut would be all the way down here. Okay. So from this point to that point is your minimum radius. I literally thought I just had a camera here and I was putting my hand on the screen pointing. So still learning, ladies and gentlemen. All right. So that is your minimum radius. If you come down here, oh, and I forgot. Look at this slacker. Oops. A. And it's going to be in red, and we're going to keep it. So this would be your, what I call running profile axial. How did I get to that number? See this 16th of an inch. How did I get that? Well, again, we find our minimum radius. I said, I'm telling our grinderman come down 0.063 and then go to the right until you hit the tool. So right in here, when he looks on the optical comparator in the grinding room, he's in space right here. He's in white space. When he goes over this line is where he will hit the tool. So that's a radial movement, 0.063 down, and then just go over till you hit the knife, and then hit save on the computer. When he does that, that is our, when he hits save, wherever he hits the tool, that would be our tool axial. So in a perfect world, we run our tooling off of 10 millimeters or 394. So that is probably on the optical comparator in the grinding room, 1.3537. And I think in the grinding room, it's 3 digits. So it might round it up to 1.356. That would be his tool axial. Okay. What the machine is doing is taking your tool axial minus 394, which gets you 0.9597. This is how, when you're running a Weinig moulder, you can set up the profile efficiently and accurately every time, even after sharpening the tool, because we're using the same math every time. Because the dimensions over time, when the tooling gets reground, will change. Your min and max will change. But doing a movement like this, 0.063 down over till you hit the tool, that will guarantee that when this number changes slightly after a regrind, because we're using 394, it will always position in the machine correctly. That's the beauty of Weinig's axial constant system, and why their machines are so accurate. At the end of the day, the grinderman has to do a good job, but even if he or she doesn't grind at a perfect 394 within reason, let's just say if you were even within 0.03, that's okay. Oh boy, I just got interrupted and lost my train of thought. But that is the beauty of Weinig's system, and is if you use this correctly. Oh, sorry, that's what I was gonna say. If your grind is even off 0.03, let's say, as long as you make that movement, go over and hit save, that's okay. So maybe on the machine, it doesn't come out to 394 for your axial. For this would be the second top head. Maybe it's 0.42. That's okay. It doesn't matter because you measured it correctly to a reference point that makes sense to the tool. So it's going to run correctly. Every now and then we have to make micro adjustments, 0.01-ish. And also, too, that could be that your machine itself is out of calibration. That's why it's good every year to have a PM done by a Weinig technician. They can recalibrate your machine, but also you learn that in the class, so you can do that too when you go to Weinig. So just to finish up, this right here is saying the dimension of the tool. That's your blue line. 2.25 is your depth. 2.688 is your width. How did you get there? Your knife should be 3/4 of an inch oversized of the profile. There's a quarter in the way. 1.938 plus 0.3575. Sorry. 2.688. So there's your width. How did you get the depth? Well, this will be the last one here. So your depth of profile, I call it depth of cut, is 0.5821. You're finding your minimum radius to your maximum radius, essentially. 5821. 0.5821 plus 1.5 is what Weinig tells you to use. That's their formula. So you're at 2.08 for your tool needed. Well, you really don't want to round down. Okay, that kind of throws off this whole measuring system. You should always round up. Why should you always round up as well? Because then you can get more life out of the tool. You get way more sharpens if you round up. So 2.08 to the next 1/4 inch, because the steel is sold in 2, 2.25, 2.5, 2 3/4. And I think that's the largest that I know of that our machine can handle. So 2.08, the next 1/4 inch of steel that we stock is 2.25. So that is it. This is how you draft on a molding, and then turn it into a template and a tool. Then we take this file, we send it to the water jet, it rough cuts it, then we take it and we put it in a tool holder Weinig tool holder, and we do finish passes on it. So we do a finish roughing pass and a finish pass at 25 degrees, and we do our side clearance. The water jet does not do the side clearance perfectly, so we have to go in and do that still manually on the grinder. But I hope that helped. This was kind of a real nuts and bolts video. And yeah, if you have any more, if you have a more efficient way of drawing molding, please let me know, and I would love to try it out. I'm always looking to find ways to draft faster and more efficiently. So I hope this is helpful. If anyone has any questions, I have been doing this now for 16 years, and I'd be happy to answer an email or a comment if you want to comment publicly, whatever helps. Thank you so much for watching, guys, and we will see you on the next one.